If you have root x, it is 1 by 2 root x. So therefore this becomes 1 divided by 2 root of x square minus a square. The standard integral of the form 1 divided by root of x square plus a square can be written as log of modulus x plus root of x square plus a square plus integration constant. So whatever you write, it is 1 plus x square or x square plus 1, it is one and the same. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So today in this session, we are going to study about the integration of some special functions. So here, along with that, we have few more standard integral which has to be studied, and the proof is necessary, which is done by the integration by parts. So in our previous session, we have learned some standard integrals of the form dx divided by x square plus a square, dx divided by a square minus x square, dx divided by x square minus a square. Along with that, we have also studied under the square root of these functions. So whenever the functions are in the denominators of this form, or quadratic equations, then we have learned some standard integrals and their proofs also, which is for 5-mark question. So along with this 6 integrals, we have few more integrals, that is integration of root x square minus a square dx, integration of root x square plus a square dx, integration of root a square minus x square dx. And whenever these type of integrals are come or are reduced in this form, then you can write this integral in this form. That is, whenever you have x square minus a square under the square root with respect to dx, you have to write x by 2 root of x square minus a square by 2 log of x plus root of x square minus a square plus c. And similarly, if you have x square plus a square, here you are going to write root of x square plus a square. And whenever you have a square minus x square, x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. So when any quadratic equation is given within the square root, like ax square plus bx plus c form is given. So whenever any quadratic equation is given in this form, then you will reduce this quadratic equation in any one of the forms and write its standard integrals as given. Again, this is also an important 5-mark question which may be asked for your examination. So you have to prove these results, and along with this, one sub-question is given with numerical problems. So therefore, a 5-mark question in the form of 4 plus 1 mark. Now, let's see the proof of these integrals. This is done with the help of integration by parts. So let me consider the first integral. So root of x square minus a square dx. So let me consider this integral as I. Why I'll repeat? Because this is a continuous process where you will get repeated of root x square minus a square. Therefore, whenever you get root x square minus a square dx, you can just replace it by I here. So as we have done in the previous session. Now again here we have only one function. So when you want to apply an integral, you need one more function. For example, we have taken integration of tan inverse x with respect to dx, and there we have considered 1 into dx. So here also I'll take this as into 1 with respect to dx. Now I have two functions, first function and second function is 1. Now apply the integration by parts. So root of, so what does the rule says? First function into integral of second minus integral of second into derivative of first function. Now here we have root of x square minus a square. What is integration of 1 with respect to x? It is x. Next here we have x into, what is derivative of root x? If you have root x, it is 1 by 2 root x. So therefore this becomes 1 divided by 2 root of x square minus a square. But x square minus a square is again one more function derived. When you derive x square, it is 2x. And when you derive a square, it is 0 because it's a constant. So here we have this function with respect to dx. 2 and 2 get cancels here. So now you have here x into x, x square. So therefore now this becomes root x square minus a square. You can multiply x minus x square divided by x square minus a square into dx. So what I will do here, I will subtract a square and add a square here. Then I will separate this. This is under the square root we have. I will subtract a square and add a square, and here I have square root of x square minus a square. So here this becomes I is equal to x into root of x square minus a square minus integral of x square minus a square divided by root of x square minus a square plus a square divided by root of x square minus a square with respect to dx. So now this is in the form of x divided by root x. So you can see x square minus a square can be written as 2 times square root of x square minus a square. So root of x square minus a square get cancels. We have I is equal to x into root of x square minus a square multiply minus inside the function it becomes root of x square minus a square dx. Again here minus into plus we have minus a square we can take it outside. Integral of 1 over root of x square minus a square with respect to dx. Remember the standard integral of this form. 1 over root of x square minus a square can be written as log of modulus x plus root of x square minus a square. So this is the standard integral and its value is log of x plus root of x square minus a square. Here a square is outside, so I will write it outside the function. Next here, look here, root of x square minus a square dx. Initially we have taken it as I. So therefore, here I will write this as I. And here it is as it is. Here we have I. When you shift I here, this becomes 2I is equal to x into root of x square minus a square. And here we have minus a square log of modulus x plus root of x square minus a square plus integration constant. So here also you can write plus integration constant. Now I need only I. So I is equal to, here it becomes x divided by 2 root of x square minus a square minus a square by 2 log of x plus root of x square minus a square plus c. So what is I we have taken? I we have taken as integral of square root of x square minus a square with respect to dx. So this is equal to x by 2 root of x square minus a square minus a square by 2 log of modulus x plus root of x square minus a square plus c. So this is the result we need to prove. So this is what the integral says, that is square root of x square minus a square dx integral value is x by 2 root of x square minus a square by 2 log of x plus root of x square minus a square plus integration constant. Let us prove the second one in the same manner. Here also we are going to apply the integration by parts. So let I is equal to square root of x square plus a square into 1 with respect to x. So therefore I is equal to first function into integral of second minus integral of second function and derivative of root of x square plus a square with respect to x now. So now here we have root of x square plus a square into x minus x into. So what is derivative of root x? It is 1 by 2 root x. So therefore it is 1 by 2 root of x square plus a square. Now x square plus a square, when you derive it, it becomes 2x. Here outside with respect to x now, 2 get cancels. Again we have I is equal to root of x square plus a square. Here you can take x first minus integral of, here you have x square divided by x square plus a square. Here also you can add a square and subtract a square, then integrate with respect to dx. So here you can take x square plus a square separately. So this is under the square root in the denominator. Again applying the same, we will get I is equal to x into root of x square plus a square minus integral of, so here this becomes root x square plus a square minus a square divided by root x square plus a square with respect to x. Now apply the integral towards the function separately. So therefore I is equal to x into root of x square plus a square minus integral of root of x square plus a square into dx. And here we have minus into minus, which becomes plus a square integral of 1 divided by root of x square plus a square dx. The standard integral of the form 1 divided by root of x square plus a square can be written as log of modulus x plus root of x square plus a square plus integration constant. And here we have a square outside. This can be clearly written as I, as we have taken I as root x square plus a square. So therefore this is minus I, and here it is one and the same, that is x into x square plus a square I. When you shift I here, this becomes 2I is equal to x into root of x square plus a square log of modulus x plus root of x square plus a square plus c. Now here I need only I. So therefore I is equal to x divided by 2 root of x square plus a square divided by 2 log of root of x plus root of x square plus a square plus integration constant. What is I we have taken? I we have taken as integration of root of x square plus a square with respect to x. Hence, root of x square plus a square can be written as x by 2 root of x square plus a square by 2 log of x plus root of x square plus a square. So, this is the standard integral. Next one will show that root of a square minus x square dx is x by 2 root of a square minus x square plus a square by 2 sine inverse x divided by a. So, let I is equal to integral of root of a square minus x square into 1. Now, apply the integration by parts. First function, integral of the second minus integral of the second into derivative of root of a square minus x square with respect to x. Now here I, integral of 1 becomes x, so this becomes x into root of a square minus x square. And here minus integral of, what is integral of 1? It is x. Derivative of root x, it is in the form of 1 by 2 root a square minus x square. And here again differentiating it, a square is 0, minus x square becomes minus 2x. With respect to dx here, 2 and 2 get cancels. So, I is now x into root of a square minus a square minus x into x is minus x square divided by root of a square minus ax square with respect to dx. So let me add a square and subtract a square. So what happens now? This becomes I is equal to x into root of a square minus x square minus integral of a square minus x square divided by root of a square minus x square minus a square divided by root of a square minus x square outside with respect to x. So now here the numerator becomes cancelling, we get root of a square minus x square, apply the integral separately, minus into minus is plus, integral, keep a square outside, 1 divided by root of a square minus x square with respect to x. Now this can be written as I, and here we have a square as constant. This is the standard integral whose value is sine inverse x by a plus c. So therefore now this is as usual, which is I. So I minus I when comes here, it is 2I x into root of a square minus x square plus a square sine inverse x by a plus c. So I is equal to x into root of a square minus x square plus a square into sine inverse x by a plus c. So what is I we have taken? I we have taken it as root of a square minus x square into dx. So thus root of a square minus x square is x into root of a square minus a square plus a square into sine inverse x by a plus c. Now let's take problems based on these type of standard integrals. So whenever equations is given, reduce it into one of the forms, write directly the standard value of the integral. First one is integral of root of x square plus 2x plus 5. I can write this as integral of, when you add 1 and subtract 1, this become x plus 1 whole square plus 4 with respect to dx. So here this can be written as x plus 1 whole square plus 2 square dx. Now this is of the standard integral of the form x square plus a square. So what is root of x square plus a square? It is x by 2. In the place of x you have x plus 1. So therefore you can write it as 1 by 2 times x plus 1 root of x square plus a square we need. But x square plus a square is nothing but this only. Remember here x plus 1 whole square plus 2 square is nothing but this quadratic equation. Therefore in the place of x square plus a square, wherever in the answer you can directly write the value as x square plus 2x plus 5. Next is plus a square. What is a square? It is 4. So therefore 4 by 2 log of modulus x. X is nothing but x plus 1 plus square root of x square plus a square. Again x square plus a square is nothing but x square plus 2x plus 5 plus c. So therefore the value is half into x plus 1 root of x square plus 2x plus 5 cancels, 2 times log of x plus 1, you can write it in bracket if you need, plus square root of x square plus 2x plus 5 plus c. So this is the value of the given integral, and this is for 1 marks because no need to evaluate the integral. You are just reducing it to standard form and writing the standard integral. Next, root of 3 minus 2x minus x square. So let us see what is 3 minus 2x minus x square. Take minus outside, then it is x square plus 2x minus 3. Add 1, subtract 1. Then this is a plus b whole square. And here it is minus 4. So, and this can be written as 4 minus x plus 1 whole square. So, therefore, here you can write this as integral of 4 minus x plus 1 whole square with respect to dx. Or you can write this in the form of 2 square minus x plus 1 whole square dx. Now, this is of the form root of a square minus x square. What is the standard form of root of a square minus x square? It is again x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. So, therefore, here half into x under the square root x square plus a square is nothing but 3 minus 2x minus x square plus a square by 2. Here a square is nothing but 4. So, it is 4 by 2 sine inverse x by a. What is x? X plus 1. What is a? Value of a is 2 plus c. So, therefore, the answer is 1 by 2 x plus 1 square root of 3 minus 2x minus x square plus 2 times sine inverse of x plus 1 divided by 2 plus integration constant. Next one, x square minus 8x plus 7. So, here x square minus 8x plus 7 we have. Now, this is x square minus 8x. If you take this as in the form of 2ab, we have 2 4s. So, therefore, add 4 square, subtract 4 square here. So, then this become x minus 4 whole square minus 16 plus 7 becomes minus 9. So, therefore, I can write this integral as root of x minus 4 whole square minus 9 dx or root of x minus 4 whole square minus 3 square into dx. So, this is x square and this is a square. Now, this is the standard integral of the form x square minus a square. What is the value? It is half into x. What is x? X minus 4 into square root of x square minus a square. So, x square minus a square is nothing but x square minus 8x plus 7. You can also write x square minus a square in this form also. Since we have simplified already, we can rewrite it as x square minus 8x plus 7. Next, we have minus, we need a square. So, a square is 3 square, which is nothing but 9 by 2 log of x is nothing but x minus 4 plus root of x square minus a square again, which is nothing but x square minus 8x plus 7 plus c. So, this is the value of the given integral. Next one, 4 minus x square. So, now this is root of 2 square minus x square dx. So, this is the standard integral of the form a square minus x square. So, therefore, the value is, so 1 by 2 times x into root of a square minus x square is 4 minus x square plus a square is 4 by 2 sine inverse x by a means x divided by 2 plus c. So, the value is x by 2 root of 4 minus x square plus 2 times sine inverse x by 2 plus c. Next, 1 plus x square. So, this can in the form of a square plus x square, or it is nothing but x square plus a square. You can rewrite it as x square plus 1 also, which is one and the same. So, whatever you write, it is 1 plus x square or x square plus 1, it is one and the same. So, the standard integral of this form is 1 by 2 times x root of x square plus a square, which is nothing but 1 plus x square plus a square. A square is nothing but 1. So, 1 by 2 times log x. X is x only. Under the square root, x square plus a square, which is nothing but 1 plus x square plus c. So, This is the value of the given integral. So like this, when you know the standard integrals of all these forms, you can directly reduce the quadratic equation into standard form and write the value of the standard integral. Again, these standard integrals, they may ask you for 5 mark question. So what are the standard integrals for 5 marks question they may ask you? The first one is, they may ask you to prove integral of the form x square plus a square or integral of the form x square minus a square or integral of the form a square minus x square. So these are the 3 forms, and another thing is root of dx divided by root of x square plus a square or integral of dx divided by root of x square minus a square or integral of dx divided by root of a square minus x square. So other 3 is what we have discussed today, that is root of x square minus a square dx, root of x square plus a square dx and root of a square minus x square dx. So thus these are the 5 mark questions they may ask you to prove. So you want to prove these results, and there will be one mark question of this type. So proving this result and solving the problem is a 5 mark question. These are all the standard integrals which are very important to evaluate quadratic equations in the form of these 9 integrals. So we'll meet you in the next session with few more concepts of integrations. Until then, keep watching, keep learning, keep exploring. Thank you.